Okay, this is a fun little example. What we have here is a block A, which has a mass of m, an initial speed of v1, and we're told that the block moves to the right on a rough horizontal surface, which has a coefficient of kinetic friction of mu k. We're told as the block slides, a force f of tx to the right on the block, with the time history for f of t being shown below. Based on this, we're asked to determine the speed of the block delta t, and the speed of the block at t equals 2 delta t. Alright, so to start out this problem, because we're looking at essentially a kinetics problem here, I'm going to start by drawing a free body diagram for the block, treating it as a particle. So in this case, I know there's an applied force F. We have also the weight of the block mg. There'll be a normal force between ground, and I'll have the friction force here, little f. To help myself out in this problem, I'm actually going to start before I even use the linear impulse momentum technique and solve for the friction force, because I'm going to need that. And so if I do that, noting that the sum of forces in the y direction is equal to 0, I'll have n is equal to mg. And this, of course, is going to give me that f, which is equal to mu k times n, is equal to mu k times mg. Now that I have that in hand, I can go ahead and apply the linear impulse momentum equation in the x direction. And if I do that, what I'm going to get here is that m times v1 plus the integral of f minus f, that is the applied force minus the friction force, dt, is going to equal, in this case, the mass of the particle at state 2, which is the same, times the velocity in the x direction at state 2, which is simply v2. Now, in this case, we know that the force profile changes at a time delta t, and so if we're looking at parts A and B of this problem, we're basically looking at the parts where this friction force changes its form. So if we do that, if I look at part A, where we're only interested in the interval from time 0 to delta t, I'm going to have that mv1 plus the integral from time 0 to delta t of the applied force F, which over this interval is simply F naught, minus the friction force, which we said was mu k times m times g, times dt is going to equal mv2. If I go ahead and expand this expression, what I'm going to have is that m times v1 plus quantity f naught minus mu k times mg times delta t is going to equal mv2. And if we look at that, we realize there's only a single unknown in that equation, v2, so we can solve for that to get the speed v2, from which we can say, of course, that the velocity at state 2 is simply v2 in the little I direction, where I assume, of course, that I and j are oriented as classically done in Cartesian coordinate set. Now part B is going to be a little bit bigger challenge. What I have now is I have the mv1 plus the integral now from 0 to 2 delta t of f minus f dt is equal to m times v2. And I'm going to ask you to note that essentially this integral can be split over two domains, a domain from 0 to delta t and a separate domain from delta t to 2 delta t. So that's what I'm going to want to do here to make my life a little easier. Let me add a little space to do that. So if I do that, I'm going to have the first term is mv1. I'm going to add to that the integral from 0 to time delta t of f, which over that range is simply f naught, minus f, which is mu k times m times g, dt. And then I'm going to add to that the integral from delta t to 2 delta t. I'm going to have the value of the force over that interval, which is given by, in this case, f naught. Excuse me, it's actually going to be equal to, let me go back to the top, it's going to be 2 f naught minus f naught over delta t times t minus, that's the f part, the big F, and then I'll subtract off the friction, so minus mu k mg dt, and that's going to equal, of course, m times v2. This function right here that appears, and let me maybe highlight it in a different color here for you, is essentially the function for the line given up here in the diagram. And you can check that, namely it's this line right here, you can check that by ensuring that at time delta t it's equal to f naught, which indeed is the case, and at time 2 delta t it's equal to 0, which again is indeed the case. So with that in hand, I can go ahead and start to expand this expression. And so if I do that, the first term is going to give me m times v1. The next term is going to give me f naught minus mu k times mg times delta t. From the next term, I'm going to go ahead and do the integration in the first step. So I'm going to have 2 times f naught times t minus f naught times t squared divided by 2 times delta t minus mu k times mg times t, evaluate at delta t and 2 delta t, and that's going to equal m times v2. If I expand this again, I'm going to have m times v1 plus f naught times delta t minus mu k times mg times delta t. And then from my definite integral here, I'm going to have plus 4 times f naught times delta t minus 4 times f naught times delta t squared divided by 2 times delta t minus 2 times mu k times mg times delta t minus quantity 2 f naught times delta t minus f naught times delta t squared divided by 2 times delta t minus mu k times mg times delta t. And that's going to equal m times v2. We can clean this up quite a bit. So if I do that, I'm going to have m v1. If I look outside the parentheses here, I have 5 f naught times delta t minus mu k times mg times delta t. This here, a delta t is going to cancel, so I'm going to have minus 2 times f naught times delta t minus 2 times mu k times mg times delta t minus 2 f naught times delta t plus f naught times delta t over 2 plus mu k times mg times delta t is equal to m v2. Oops, pardon me here, let me pan back up. If I look at my math carefully here, you'll note that this term and this term are going to cancel out. And so what I'm going to be left with here is m times v1. I have 5 minus 2 minus 2, which is 1 plus 1, so I have plus 3 f naught delta t over 2 is going to equal, minus 2 times mu k times mg times delta t is going to equal m times v2. And from that, you can go ahead and solve for v2 and get the final answer for this problem. Best of luck, everybody. Take care.